Okay, so this is my first attempt at standard 1.3. I decided to do question 1.2, which asked us to find a normalized vector that is orthogonal to the three various vectors shown here. That was for part A, and for part B we were just asked to calculate the inner products between all the vectors. So for part A, I simply set up this vector with the coefficients. And we know that if we find the inner product and set equal to 0, that they'll be orthogonal. So running through this, we got our coefficients here, and setting them equal to 0, we get the complex conjugates. So to get the regular coefficient, we just take the conjugate, and we get these two coefficients, which gives us our vector that is orthogonal to phi 1. Essentially, we go through the same thing again for phi 2. We run through, do the inner product again. We get our coefficients, and again we have to find the complex conjugate. And for this one, we had to normalize the vector because it was not normalized already. So again, we just take the inner product with itself and set it equal to 1 and solve for the coefficient, which was 2 over root 5. So we multiply that through to the coefficients, and we get this phi 2 for our orthogonal vector. And once again, we go through the same process for phi 3, except for this one, we had this coefficient e to the I pi over 4 times the square root of 2, which is a little tricky to work with. So instead, I use this triangle to convert it to 1 plus I over root 2. Again, run through the same process, and we get these two coefficients. And we take the conjugate again, and then we go to normalize. Again, we just take the inner product with itself and set it equal to 1, which gives us the coefficient that we multiply by. I multiply that through to get phi 3, which is our orthogonal vector for phi 3. Then for part B, we just do the inner products of all three. It's pretty simple, just whichever phi comes first, you have to make sure to take the conjugate of the coefficients. Just run that through so you can see my answers. It's basically the same process for each one. And yeah, that's about it.